Hello science fans, today we're diving into the fascinating world of alcohols, starting with the most basic one of all. Meet methanol, the simplest alcohol molecule, but don't let its simplicity fool you. This tiny compound has a huge impact on our world, both in industry and in nature. Its chemical formula is CH3OH, which means it's made up of just one carbon atom, 3 hydrogens, and a single hydroxyl group. This structure makes it the foundation for understanding all other alcohols. Methanol is a clear, colorless liquid that looks almost identical to water. It mixes with water in any proportion, making it tricky to tell apart just by looking. Its faint, sweet odor is subtle and can be easily confused with ethanol, the alcohol found in beverages. But don't be deceived, methanol is very different and much more dangerous. Methanol is never meant for drinking. It's a powerful industrial chemical used in countless manufacturing processes and products. While tiny amounts of methanol occur naturally in fruits, vegetables, and even inside our own bodies, the methanol produced for industry is highly concentrated and extremely hazardous to humans. Methanol is incredibly versatile. It burns with a clean, almost invisible blue flame, making it useful as a fuel in certain specialized engines and stoves. It's also a universal solvent, able to dissolve a wide range of substances that water cannot, which is why it's so valuable in laboratories and industry. Methanol can be produced from natural gas, making it a key player in the energy sector. But that's not all. It can also be made from renewable resources like wood, or even from captured carbon dioxide, offering exciting possibilities for sustainable chemistry. Because of these flexible production methods, methanol is one of the most widely produced chemicals on the planet, with millions of tons made every year. Think of methanol as a basic Lego brick for chemists. It's a starting point for making plastics, synthetic fuels, medicines, and countless other products that shape our modern lives. It's truly a cornerstone of the chemical industry, quietly supporting the creation of everything from everyday household goods to advanced pharmaceuticals. But remember, methanol is a double-edged tool. It's incredibly useful, but also highly toxic and dangerous if mishandled or ingested. Understanding this dual nature, its power and its risks, is essential for appreciating methanol's vital role in science, industry, and even in our daily lives. So next time you hear about methanol, you'll know just how important and fascinating this simple alcohol really is. Here's the most crucial fact. Methanol is a potent and insidious poison, often mistaken for ethanol, the type of alcohol found in beverages. This confusion can have devastating consequences, especially because methanol is colorless and has a similar smell and taste to ethanol, making it nearly impossible to distinguish without proper testing. Its similarity in look, smell, and taste has led to tragic poisonings worldwide, particularly when people unknowingly consume contaminated or illicit alcohol. In many cases, victims are unaware they've ingested methanol until symptoms appear, often too late for easy treatment. The body tries to process methanol just like ethanol, but the liver's enzymes convert it into formaldehyde, a substance far more toxic than the original alcohol. This chemical transformation is what makes methanol so dangerous. Formaldehyde is then rapidly converted into formic acid, a systemic poison that disrupts the body's pH balance and attacks the nervous system. This cascade of toxic reactions can quickly overwhelm the body's defenses. Formic acid blocks cells from using oxygen, starving them of energy even when oxygen is present in the blood. This cellular suffocation is what leads to the most severe symptoms of methanol poisoning. Early symptoms, headache, dizziness, nausea, are easily mistaken for a simple hangover or mild illness, which often delays people from seeking urgent medical help. As poisoning progresses, vision blurs, pain intensifies, and breathing becomes difficult. Some people may experience confusion, agitation, or even hallucinations as the toxins affect the brain. Without prompt treatment, methanol poisoning can cause irreversible blindness, kidney failure, seizures, coma, and ultimately, death. The window for effective intervention is frighteningly short. The real danger is the silent, deadly chemical reaction happening inside the body, often unnoticed until severe damage has already occurred. Even small amounts of methanol can be catastrophic. Just a few milliliters can cause permanent injury or death if not treated quickly. Recognizing the symptoms early and seeking immediate medical attention is absolutely critical to survival and recovery. Methanol's deceptive nature makes it one of the most dangerous chemicals in everyday life. Always handle it with extreme caution and never underestimate the risks it poses. One of methanol poisoning's most tragic effects is blindness. Formic acid attacks the optic nerve, which is packed with mitochondria, our cells' power plants. When these mitochondria are shut down, optic nerve cells swell and die, often irreversibly. Just 2 teaspoons of methanol can cause blindness. 2 tablespoons can be fatal. The antidote: ethanol, the drinking alcohol. Doctors give ethanol to outcompete methanol for the liver's enzymes, slowing the formation of toxic byproducts. This buys time for the body to excrete methanol safely. In hospitals, fomepizole is often used instead, as it's easier to dose and has fewer side effects. Supportive care and correcting the body's acid balance are also vital. This is a brilliant example of chemistry saving lives, using one alcohol to block the effects of another. Quick action can mean the difference between life, blindness, or death. Before the breakthroughs of modern chemistry, methanol was produced in a surprisingly simple yet labor-intensive way. People would heat wood in large iron retorts, carefully controlling the oxygen to create low-oxygen conditions, a process known as destructive distillation. This ancient technique was both an art and a science, requiring skill to avoid burning the wood and losing the precious liquid. The resulting liquid was called wood alcohol, because it was literally distilled from wood, and its name stuck for centuries. Even in ancient times, the Egyptians used wood-derived methanol in their embalming rituals, helping to preserve bodies for the afterlife. However, the substance itself wasn't isolated or truly understood until the 1600s. In 1661, the pioneering scientist Robert Boyle first managed to produce methanol in a more recognizable form. For hundreds of years after, it found use as lamp fuel, a cleaning solvent, and even in early medicine. By the 1830s, French chemists Jean-Baptiste Dumas and Eugène Pelligot finally determined its chemical composition. They gave it the name methyl alcohol, meaning wine from wood, and opened the door to understanding its true nature. But the old process was far from perfect. It required vast amounts of timber, and the methanol produced was often impure, contaminated with other chemicals from the wood. Sometimes these impurities were left in on purpose to discourage people from drinking it, a crude but effective early form of denaturing, meant to keep the public safe. As demand for methanol grew, wood distillation plants struggled to keep up. The process was slow, resource-intensive, and couldn't match the needs of a rapidly industrializing world. Eventually, science provided a breakthrough, a cleaner, more efficient, and scalable way to produce methanol using new chemical methods and industrial technology. As a result, the age of wood alcohol gradually faded into history, replaced by the rise of industrial chemistry and modern manufacturing. Yet, the story of methanol was only just beginning as new uses and possibilities emerged with each scientific advance. From ancient rituals and mummification to powering lamps and fueling industry, methanol has always been a chemical of consequence, shaping human history in unexpected ways. But as the world changed, the future would demand even more from this remarkable substance, setting the stage for methanol's next great chapter. Today, methanol is made from natural gas, not wood. The process starts with steam methane reforming. Methane and steam react at high temperatures to form syngas, a mix of carbon monoxide and hydrogen. Syngas is then passed over a copper-zinc-alumina catalyst at high pressure, forming methanol. The hot methanol gas is cooled and condensed into a liquid, then purified by distillation. This efficient continuous process produces thousands of tons daily. Modern plants deliver methanol at over 99.8% purity. It's a triumph of chemical engineering, turning a simple gas into a vital industrial liquid. Methanol production now meets the world's vast demand cleanly and efficiently. Methanol's real power is as a chemical building block. Most methanol isn't used directly, it's transformed into other essential chemicals. The biggest use making formaldehyde, which is vital for resins, adhesives, and plastics in construction and furniture. Methanol is also used to make acetic acid, the precursor for PET plastics. adhesives, and coatings. It's a starting point for silicones, acrylic plastics, solvents, and more. From plywood to soda bottles, methanol is behind the scenes. Its simple structure makes it the foundation for a vast range of products. The influence of methanol is everywhere, in homes, cars, clothes, and electronics. It's the unsung hero of modern materials. Without methanol, much of our world would look very different. It's the invisible backbone of industry. Methanol isn't just a building block, it's a powerful fuel. Its high octane makes it ideal for race cars, burning cooler and cleaner than gasoline. Methanol's invisible flame requires special safety measures in motorsports. It's also key in making biodiesel, breaking down oils, into usable fuel for diesel engines. Methanol is used to produce MTBE, a gasoline additive that boosts octane and reduces emissions. As a marine fuel, methanol cuts pollution from ships, helping meet strict environmental standards. Methanol stoves offer cleaner cooking in developing regions, reducing indoor air pollution. It's already powering ships, power plants, and homes worldwide. Methanol is a practical, clean-burning fuel for today and tomorrow. Its versatility keeps it at the heart of the global energy mix. Methanol is emerging as a key player in green energy. It's an excellent hydrogen carrier, easy to store and transport as a liquid, unlike hydrogen gas. Methanol can be converted back to hydrogen at the point of use, acting as a liquid battery. Even more exciting, green methanol, made from captured CO2 and renewable hydrogen. This creates a carbon-neutral fuel cycle. CO2 is captured, turned into methanol, burned and recaptured. Green methanol could power cars, ships, and planes without adding new carbon to the atmosphere. It's a way to store renewable energy in a stable, transportable form. Methanol could bridge the gap to a sustainable circular energy economy. Its role in decarbonizing heavy industry and transport is just beginning. Methanol is at the center of the clean energy revolution. Methanol is a molecule of contrasts, simple, yet essential, dangerous, yet life-saving. It's woven into the fabric of modern life, from materials to fuels. Its production is a triumph of engineering, and its uses are ever-expanding. Methanol's dangers demand respect and strict safety, but its promise is immense. As a hydrogen carrier and green fuel, it could help decarbonize our world. Methanol is evolving from a fossil fuel product to a bridge for a sustainable future. Remember its two faces, the poison and the promise. With wisdom and science, we can harness methanol for good. The science is clear. Methanol's power is in our hands. Consider that.